Hello everyone, welcome back. Mr. Havel here. We're going to go over 11.4 today, which is Intro to Derivatives. Okay, so we've got this graph here on the right, the blue one. It says, suppose you want to find the rate of change, or our slope, of that graph at various points on the graph, at various x's. Okay, so it says find the rate of change by calculating the slope between the two indicated points on the graph. This is called the slope of the secant line. So that's a secant line. So if you draw the two, so kind of draw a line in between, it cuts through the two, and that's a secant line. Cool. So if I'm going to find the slope between those two, what I'm going to do is find the individual points. So this is what at 2, 4. And this one is at 4, 5. So if I want to find the slope, I just take the difference in the y. So 5 minus 4 over the change in the x, 4 minus 2. So that would be what? 1/2. So our slope from an x of 2 to an x of 4, we would say it's 1/2. But if you notice, there's a lot going on right here besides just a straight line. Okay. And so we need to kind of dive more into that. So it says, assume that you were primarily interested at the rate of change f of x at the instant when x is equal to 3. How can we find the slope? Okay, so unfortunately, if I choose 3, I don't really know, right? We don't have a straight line, so we have a curve going on there, and so we need to do something different. Okay. So it says, no, we can call this the slope of the tangent line. Remember, it just touches it one time. So the tangent line there. Okay. And so what we're going to do is, if you notice on here, I want this slope right there. And so what we're going to end up doing is we're going to end up moving our 2 points closer and closer and closer to each other, so I can get a good representation at x is equal to 3. Okay, and so what we're going to do, we'll put that down. We're going to move your points very close to x equals 3, because that's where I want to know what we'll find the instantaneous velocity or instantaneous slope right there at x is equal to 3. Okay, so it says here the slope of the secant line that we found earlier, right, in that first part of it, can be used to approximate or kind of estimate the slope of the tangent line at x equals 3. Okay, if you notice when we drew those lines, they looked pretty similar, right? Not totally correct, but pretty similar. It says, how could we make this approximation closer to the actual slope at x is equal to 3? Okay, and so again, same idea here. We're going to move each of those points closer and closer and closer to 3 itself. Okay. So here, if you notice, it looks kind of crazy, but here we have an x value, and then this is a fancy way of writing y, so the function f of x. And then here, what we're going to do beyond this is we're going to take that initial x value, I'll write it down here a little bit, and think about all of our hk that we've done in the past. Okay, so I'm going to do it down here because there's so much writing. But going from the blue dot to the black dot, if you notice, we have x right here, and we're going to move over a value of what we call h. Okay, so our initial one's at x, our new one's going to be x plus h. Same idea for the y. We're going to start right here at the y, or we could call it f of x, and then we're going to go up a certain amount as well and call that f of x plus h. Okay, so that change there is going to change our y value as well. Okay, and so if we do the slope of these with, it looks weird, but with these values now, instead of actual numbers, we're going to take the first one. So we're going to do f of x plus h, that first y, minus f of x. And then we're going to do x plus h minus the other x. And if you notice, they both have the x in common in the denominator, so we can get rid of those guys. And we're left with f of x plus h minus f of x all over h. And so what that's going to give us is it's going to give us a slope in between those 2 points there, right? And so it says use limits to move the 2 points closer until they are at the same location. So we're going to use this idea right here, but I want to limit it so this h value is as close as possible. So I want to get this line, I want to move it over, move it over, move it over until it's as close as possible, or if we would say the distance between them would be 0. Okay, so the way we're going to do that is we're going to say the limit as h, not x, h approaches 0. So if I get it super duper close there, that they're pretty much on top of each other. So of this slope right here, f of x plus h, what we just found right above. Cool. And so that's what we're going to use to figure out the slope at any given point, at one point on with a curvy line there. Okay. So this is one of the main areas of interest in the study of calculus. The rate of change, okay, of a function at one point is also called the instantaneous rate of change, or the derivative of a function. Okay, and so this is the definition of a derivative here. So we're going to use that to find the instantaneous change at an individual point. Cool. And so we've got all of these, this table here. So I might pause it real quick so I can write it all down, and then you can write it as well, and then I'll explain it. Okay, perfect. I was able to write a bunch of this stuff down. So here, limit definition, that's what we just found above, this guy. Equivalent phrases that you might hear the slope of a tangent line, the instantaneous rate of change, instantaneous velocity. Some of you taking physics might go, oh yeah, I've heard that one before. And so that's all we're doing. Notation on the second one. There's different ways to write it. You'll see f prime or y prime, that's these guys, and then or dy dx, the derivative of y with respect to x. Okay, find the slope. Okay, so we're going to evaluate f prime at a specific point. So we'll take that derivative and then we'll plug in, say we want to know at x is equal to 2. So we'll plug it in here, and that will be that instantaneous slope at x is equal to 2. Now writing it in HK form, right, we should be really familiar with this top one. It's just the slope in HK of a line. Well, this new one, the only difference is we're gonna have to find that slope a different way than just a normal line, but still the h and k setup is going to be exactly the same. Cool. So number 1 and 2 below, it says find the derivative by using the definition. Cool. And so as we go through this, I always have students struggle with it at the beginning, but remember, you guys are super comfortable. You don't have to write this down. But if I gave you something like this, f of 2 of x plus 1, what would you do with that? Well, this is f of x, and so you should plug it in. So f of 2 would be 2 plus 1, which is 3. Okay? And so when we use the limit definition, all we're going to do is we're going to plug this one in, and then we're going to come back and plug this in, and then we're going to put it all divided by h, right? So what that tells me is for the first step, wherever I see an x, I'm going to plug in x plus h. Right, so my limit as h approaches 0 of 3, and then I plug in x plus h, minus 2, right? So I'm just substituting it in. So I'm done with the first one, first part of it. I'll highlight it in yellow here. Okay. Now my second part is I'm going to go through and I'm going to do minus it says just minus the equation, right? So minus 3x minus 2. Make sure we got parentheses because we see a lot of times that mistake of not distributing in the negative, okay? And so this is the second part of it. And that's it, okay? And now it's all over h. And now what you're gonna do is just clean up everything, okay? You'll notice the stuff in blue is gonna cancel out, okay? So when I kind of start cleaning up stuff, limit as h approaches 0, distribute in, I've got 3x plus 3h minus 2 minus 3x plus 2 over h. And again, the blue highlighted stuff, see you later, adios, adios, adios. For some reason I put a 2 down here, but I meant to put an h. Cool. And so now what I'm left with is the limit as h approaches 0 of 3h, that's pretty much it, over h. And so that cancels out, and so it goes to the limit as h approaches 0, which I don't have any 0, of 3. So since it's a constant, we just have 3. Okay. So again, that would be the equation of the slope of the tangent line. Cool? Or not the equation, but the value of it, okay? So let's try it again. So in this second one makes it a little bit more challenging because now I have an x squared. So I've got 2. I'm still going to put x plus h in here, squared minus 1. That's the first portion. Now the second portion, I'm going to subtract the entire equation all over h, okay? Now you guys are geniuses, so we don't have to, I don't have to individually FOIL this out. We'll kind of walk through it though, okay? So it'll be 2, here it's going to be x squared, and then at the end it's going to be h squared, the first and last. Then the middle is just double those two multiplied together, right? So it's going to be 2hx. I always recommend, you don't have to, but I always recommend putting it in alphabetical order so that it's easier to see, okay? And then distribute that negative in, plus 1. Now, all this is over h. Now I'm going to distribute the 2 into everything in these first parentheses. H goes to 0, so 2x squared plus 4hx plus 2h squared minus 2x squared plus 1. And you notice that second portion is going to cancel out again. So adios, adios, and adios. Did I forget something? I did. Oh my goodness. My first day, folks. I totally forgot this right here. So minus 1. It's a good check because I knew that I was going to cancel them out. So it was a good check for me to go back and catch those guys. Cool. And so now the limit, after I've canceled those out, h goes to 0. I'm left with 4hx plus 2h squared, and that's it, all over h. If you notice, they all have h in common, so I'm going to go and cancel 1h out in everyone. They all have to have it in common. They should at this point. So I have the limit as h approaches 0, and then we've got 4x plus 2h. Now our very last step that we're going to do is we're going to actually take the limit. So we're going to plug it into h of 0. And so I'm going to end up with 4x plus 2 times 0. And so I'm going to end up with 4x. And so that's the derivative of that top equations. Okay, and so I didn't write it on the first one, but just to show you the way we would write it officially is we could say g prime of x is equal to that. So that tells you that the derivative of g is 4x. Cool, cool. All right, 3 through 6, we're going to use this equation right here, x squared plus x. It says find the derivative of f, so using the limit definition. So this is going to get a little bit trickier just because we've got multiple x's there. Okay, so I'm going to plug everywhere I see an x, I'm going to plug in x plus h to start out with. Squared plus x plus h. Now the second part of the equation, I'm going to subtract the function itself. And then all of that is over h. Cool. So limit as h approaches 0. Let's FOIL this guy out. So we've got what? X squared plus 2hx plus h squared. Now we don't really have to do anything with these guys, and then distribute the negative into the last ones. Now I can't cancel the h's out now. You'll see that it's going to cancel out, but right now there's terms that don't have an h, so I can't cancel out now. But again, this cancels with this cancels with this, and if you notice a little shortcut from here, I'll kind of highlight it. Okay, we've got this guy, and that guy. So one way that you might see it sometimes, you don't have to do this, but they all have an h in common. So if I take an h out, I've got 2x plus h plus 1. Okay, all over it. Don't forget that 1 there. And then these guys cancel. And then when I take so those are gone. When I take the limit itself, I end up with 2x plus 0 plus 1, which is going to boil down to 2x plus 1. Okay. So that's the derivative. Okay. Now it says find the slope of the tangent line at 2, 6. Okay. And so what you're going to do is this tangent line and the slope, those guys are all related to that one, right? So what we're going to do is we're going to plug in f of 2, and this comes out to be 2 times 2 plus 1. Okay. And so the slope, just the slope, that's it, would be 5. Okay. So right here at 2, 6. Again, with step number 3, we found the equation for the slope of the tangent line, but then number 4 we specified and said, okay, well now I want it at 2, so I got more information. So this is the slope at x of 2. It's going to change if I did like an x of negative a half, right? So it would definitely change there. Definitely change if I did slope at negative 2, right? So each point's going to be different. Now it says put it in HK form, right? And so I can use this point right here. And so because that's going to be the point that I'm concerned about, so my new thing's going to be the slope, x opposite h, keep that k. So I wouldn't want to mix, since I found the slope of 5 at 2, 6. You don't want to choose just like a random point. We don't want to do like 0, 0 or something like that. So wherever you find the slope, you've got to use that point there. Okay. It says sketch tangent line you found in number 5. So I kind of I did it right there, kind of messy, but it's hard to graph on here. Okay. F of x is already graphed for you. Good. Good. Okay, so this one here just looks a little bit different, but the process is exactly the same. Wherever you see an x, put an x plus h, subtract the function itself, and then I'll put it all over h. So the limit as h approaches 0 of plug in x plus h, that's all that function has. So now we minus the function all over h. Now, if you notice, unfortunately, nothing cancels in the numerator. I can't plug in 0 into the denominator. It's going to make my everything go undefined. And so what we have to do, if you remember previous sections, we have to rationalize the numerator. So we're going to rationalize x plus h plus, we'll do this whole thing, the square root of x. Okay, so we multiply it by its conjugate. So I got parentheses everywhere, plus square root of x. There, that looks better. That was a little overboard in the numerator there. Okay. Now the nice thing is this in the numerator, don't overthink it. Remember, conjugates, the nice thing is you can multiply the first terms. So they match exactly. So they just get rid of those. And then the last terms right there, we're going to have minus. Again, root x times root x is just x. Now, in the denominator, most of the time, don't distribute in. Okay? So trust me on this one. Just leave it kind of as is. Put them next to each other, but don't distribute in the h yet. Now, the numerator, you're going to notice that these guys cancel. And then I'm left with h over h, and then all that extra stuff. I'm okay. Ask your teacher if they are okay with it, but I'm okay if you cancel the h's at this point too. But just to show you, you'd have h over this, x plus h plus x. Now these guys cancel. And so now I'm left with, I'll come over here, limit as h goes to 0 of 1 over this stuff, x plus h plus square root of x. And so now actually you're going to take the limit. So we end up with 1 over, notice whenever I take that limit, we get rid of writing the limit. And then so that simplifies out to 1 over 2 root x. Okay. If we don't want it in with the root in there, multiply top and bottom by root x. Okay, so we'd have root x over 2x. Either one is fine. So again, that is the derivative of the function in general. Now, if I want to get more specific and do a certain point, I just plug in 4. I plug in the h value, or sorry, holy cow, the x value. So I plug it in. This is going to be 1 over 2 root 4, which turns out to be 1/4. So that's the slope at that point. Now to write the equation, I want the slope and then the point that I was looking at. So x minus 4 plus 2. Okay, it says sketch the tangent line you found in 9. So the tangent line would be at 4, 2, 1, 2, 3, 4, 1, 2. Shabam. I'll graph in a different color. I'm going to graph square root of x in blue. So we got 0, 0, 1, 1, 4, 2. So that goes like that. And so our tangent line, here's the point, rise 1, 1, 2, 3, 4, go down 1, 1, 2, 3, 4, and so that would be the slope of my tangent line. Cool? Awesome. Nice. Now 11 and 12 here, we're coming to a close on these. So a ball is thrown straight up from a rooftop, 160 feet high, with an initial velocity of 48 feet per second. The function right there describes the ball's height above the ground in feet t seconds after it's thrown. The ball misses the rooftop on its way down and eventually strikes the ground. Okay? So given that s prime is equal to that, so our derivative, it's super nice of us, we already gave it to you. It says, what is the instantaneous velocity of the ball 2 seconds after it's thrown? So the nice part is, since we already have the derivative, we don't have to go through all that work. The instantaneous velocity is going to be that plugging that 2 in there. So s of 2, negative 32 times 2 plus 48. So what's that, negative 64-ish plus 48. So it's going to be negative 16 feet per second. Okay, that might sound crazy. I didn't think something could go negative 16 feet per second, but all that means is whoever threw the ball threw it up, and then it's going down. So maybe we'll say maybe this is t equals 2. So that's negative because it's now going down instead of going up. Cool. It says, the second one here, what is the instantaneous velocity of the ball when it hits the ground? Okay, so it says hint, find t first. Why is your answer negative? Again, we talked about the negative answer right there because it's going down. We've said that going up is positive, so therefore going down is negative. So the big thing is we need to find, okay, well, when does it hit the ground? At what time does it hit the ground? So in order for it to hit the ground, we need y to equal 0, right? Our x-intercepts. So we use our initial equation, 16t squared plus 48t plus 160. And then we're going to just factor it, take out GCF, factor it, all that kind of fun stuff, so that we can get these values. Okay, negative 3t, what would this be, minus 10? And so negative 16, what's that, t minus 5, 4, 3, 2, 1, t plus 2. And so our two t's are t is equal to 5 and negative 2. So we can have a velocity that's negative, but we don't want this guy of a t negative. Okay? Just so you know, understand why it's t is negative. Well, math, just basic math, doesn't consider necessarily the real world. So what they're doing is here we threw the ball from here. So this is a t of 5. The negative 2 is math figuring out the back side of your parabola. So that right there would be at negative 2. But we don't want that because that's doesn't make sense in our situation. Cool. So it says after 5 seconds it's going to hit the ground. So now I come back and my instantaneous velocity is plugging that 5 in, and so negative 32 times 5 plus 48. And that, when we calculate it out, is going to be negative 112 feet per second. And again, that's because it's going down. Cool beans. All right, last problem here, Hazel. So Hazel attempted to find the derivative. Which step below is correct? Okay, so we're going to kind of go through here, do a little exploration, see why things are good or not good. Okay, so on the first one here, if you look, so far it's looking good, right? So we got the negative 2, they plugged in x plus h. Good. They plugged in x plus h. Good. Now this is a super common mistake. It's negative 2x squared plus 5x. So they did kind of two things wrong here. So this should be minus negative 2x squared plus 5. So it should end up being a plus and then a minus there for those. Okay, so next steps here, there's all kinds of things wrong with B. All they did was they plugged x into each of them and then did it again, right? So they didn't even plug x plus h in, so that one is not looking good either. Very similar for the next one. They've just plugged in x to everyone, but the nice part is they actually switched the signs properly, right? So they switched these signs there, so those look good, but everything else, not everything, but a lot of those in yellow is not good. So we definitely know that at this point D should be the answer, right? But if we look, okay, the x plus h, and then this is a good thing right here, they got their signs correct finally. Okay, so that's the big difference between A and D, is you got to remember part of that equation is minus f of x. So you want to minus the whole equation. And so that's, oops, is that squared? That's squared. So then it should be a plus 2x squared minus 5. Okay, so make sure to get those signs correct. Okay, and so that one would be D. Cool. I hope you enjoyed it. I will see you next time for 11.5. Tell a friend.